In this video, we're going to learn about semantic search, the core use case for vector databases, and the backbone of a lot of modern search engines. And so semantic search has more so to do with finding the similarity in meaning between a query and a document. So we're not just finding similarity in regards to keywords anymore, like whether they have similar keywords, which was okay, but search was taken to a whole other level when semantic search and embeddings became high quality. And so we need semantic search relies on finding the semantic meaning between queries and documents and matching up those queries and documents that are most similar in semantic in meaning, right? And so the meaning, like how do we get that? We get that by using an embedding model. And so you should be very familiar with embedding models at this point in the course. And that is how we're going to get that meaning is by having a high quality embedding model. So semantic search plays a crucial role in modern search engines. It's not everything. There are a lot of other things that go on behind the hood to determine which results to return for a given query. Keyword search is not completely abandoned in most modern search engines. Usually what you'll see if you go around and look up search algorithms and search engines and you learn about it, you'll figure out that the primary search algorithms are a hybrid between semantic and keyword. We're not going to go into keyword, we're not going to learn about search algorithms, but we are going to cover semantic search and how we can do that in Pinecone. So now we're going to head over to a notebook where I'm going to show you how we can create a Pinecone index, fill it with some data, and then do semantic search on that vector index. So let's head over there. So I'm not going to cover all of this in detail because if you have the code, if you're taking this course, then you are going to have access to this code, and I'm assuming you'll be able to figure out a lot of this on your own. But I do want to cover some major things, right? So for one, this is how I am connecting to Pinecone itself. I'm creating a Pinecone client right here by passing in my API key, which you can get from your Pinecone account. And so this is a list of indexes that I currently have. And this index is the one that we are going to be using. I've already created it, obviously, for the sake of making, for the sake of time and for creating the course materials for this course. But this is you'll be able to list these indexes and be able to see this index in there after you follow these steps to build it. And so I've already done this, but load your embedding model because we are going to be embedding data to insert that in. And you can do it, you can check to see if it's working by running this cell right here on these two sentences, and you see we have two 384 dimensional embeddings. So let's get to building the vector DB. I'm going to use the CNN Daily Mail dataset that you can find on Hugging Face. You can literally search this up under datasets and it will pop up. I'm only going to take 10,000 articles from that dataset. And so this is one article from it. I've already loaded it in. And it's about Harry Potter's, Daniel Radcliffe and Harry Potter. And so I'm installing LangChain because this next step is crucial. So whenever you insert data into a vector database, you need to, unless each document, especially for text, if each document's really tiny, maybe you don't have to do this, but best practice is to chunk it. And so we split up any document that we insert into the database into smaller parts, and we're going to make sure that each part overlaps with the other, and just to make sure we don't lose context by splitting in the middle of a sentence. And so ideally those chunks are going to be around 400 tokens, and they're going to have an 80 token overlap. There are different sizes. Find which chunk size and overlap works best for your case. You'll have to test it out, but essentially this is sort of like a normal industry amount for chunk size and overlap. And I pulled LangChain in because LangChain has this recursive character text splitter module that makes sure that we're splitting on sentences and paragraphs appropriately, and it automatically writes the code to create all the chunks for us. And so this is not an industry best practice. I'm only doing this for the sake of this video. It's fine. But I'm going to, for each article, I'm going to create a duplicate for each article. And there's going to be a chunk attached to each article. And then each article is going to be inserted into the database with all of its chunks. So if this article generates 3 different chunks, I'm going to create one article for the first one, second, and then the third, and then add its chunk to each of the duplicate articles. Now, if you have hundreds of thousands or millions of documents, this is not the best practice. Best practice is to nest those chunks within the same document. So you'd have one document for the article and then a list of chunks as a metadata field for that document. So we didn't do that here because honestly, it's not really necessary. We're only going to be inserting 10,000 chunks just for the sake of demonstration. But I wanted to point that out and I wanted to make it clear so you know what the best practice is. And so here we have 10,000 chunks. I'm going to embed them with our model. And then I'm going to attach embeddings to the chunks that we have above. And so this is how you create the Pinecone index. I'm not going to go through this. It's pretty standard stuff, but I will note that I am using the dot product metric. So this is how you create vectors. You're going to create tuples. You're going to create, and they're going to be of ID, embedding, metadata pairs. So for the metadata, I'm just including a chunk index, and an article. And then I'm not going to run this because I've already done it. And then for each, I'm going to insert these in batches. And what you can do is you can call upsert. So you can pass in a batch of these tuples, ID, embedding, and metadata pairs, and then you can upsert them into the database by passing them in here as vectors. And so I'm going to call this index. I'm going to instantiate this index, and then I'm going to this is where search actually happens. So I have this function. This is how simple it is. The function is going to take in a text query. It's going to embed it, and then it's going to pass it into the query method for our index. And this is Pinecode's Python library. Pass in the embedding, the top 5 results. Say I want the metadata when you give me the results back. Each result should have metadata, and then it returns the results. And so my query is going to be the latest news and fashion. And so as you can see, for this query, latest news and fashion, it embedded it, found the documents or the chunks with the most similar embeddings. And you can see the first result is about fashion, the second result is about Ralph Lauren, the third result is about style, the fourth result is about fashion and textile museum. And so these results are semantically similar. This is just one query, but this is a good sign. Right? And so if you wanted to test this out and make sure your database is working appropriately, you would try it on many different queries, right? And so we're not going to get into testing just yet, but this is a good sign. This is how you can do semantic search with your Pinecone